Assalamualaikum and good morning everyone. We are from Group 6 and today we will be presenting our sustainable building design project. As we know, Malaysia building sector contribute around 40% of the country energy use and greenhouse gas emission. This is mostly due to poor design choice and low usage of green technology. Through this project, we aim to address those issues by proposing a smart, low-carbon building prototype that align with Malaysia's sustainable development goals and MICRES guidelines. Next, we apply the CDIO framework to guide our design process and include 4 key innovation, which is first, rainwater harvesting with grey water recycling. Second, green roof using native plant. And the third one is recycle aggregate concrete. And lastly is low E glazing. Our goal is to promote more sustainable practice in the construction industry and highlight the important role civil engineer play in creating ethical and eco-friendly infrastructure. Okay, next,
Hello, my name is Faris Izwan bin Muhammad and I will be presenting about sustainable building design innovation in relation to sustainable development goals. So, our group have chose 4 sustainable building design innovation. The first one is rainwater harvesting and green water recycling. The second one is green roof with native vegetation and recycle aggregate concrete, and last but not least is low emissivity glazing. So, the first one is rainwater harvesting and green water recycling. The related SDG is clean water and sanitation, sustainable cities and communities, and last but not least, responsible consumption and production. So, the purpose of rainwater harvesting is to collect rainwater for non-potable use. For examples like car washing or flushing or water flushing. Recycles green water from sinks or shower for reuse purpose. So the benefit by doing this, it reduces demand on municipal water supply, helps prevent urban flooding, and last but not least, promote efficient and sustainable water use. So the second one is green roof with native vegetation. The related SDG is 11. The related SDG is sustainable cities and communities, climate action, and life on land. So, green roof with native vegetation is about passive design using native plant on rooftop, such as Ipsora or Lalang. Because of their low maintenance and roof resistance, they provide isolation and reduce heat island effect. They also enhance local biodiversity and urban ecosystem, and also improve indoor comfort and reduce energy use. So next is recycle aggregate concrete. The related SDG is industry innovation and infrastructure, responsible consumption and production, and last but not least is climate action. So they use crushed concrete waste instead of natural aggregate. By doing this, it reduces construction waste and raw material usage. They also support circular economy in construction and lower carbon emission from material processing, and last but not least, encourages innovative and sustainable infrastructure. So the last sustainable building design innovation is low emissivity glazing. The related SDG is affordable and clean, sustainable cities and communities, and last but not least, climate action. This is because of their special coating reflect infrared heat, allow natural light. They reduce heat gain or loss and lowers HVAC usage. They also improve energy efficiency in building, enhance indoor comfort and quality, and last, cut down operation greenhouse gas emissions. So that's all from me. Thank you.
Assalamualaikum. Now we move to our third content of our presentation, which is sub-criteria of material and technologies according to MICRES core criteria guidelines. So this part we will cover how each innovation align with MICRES. Now let's start with rainwater harvesting and grey water recycling. So this system collect rainwater and reuse the water. So as you can see, the process shows the rainwater collect at the roof and then it flow to store of the main tank, and then we can reuse the water such as garden watering, toilet and clothes washings. So for this part, the MICRIS sub-criteria are focused on smart technologies and monitoring and controlling water system in buildings, which is these systems are used advanced technologies to monitor and control water usage, utilizing rainwater and greywater for non-potable purpose like irrigation and toilet flushing. The second one is by reducing municipal water so it can lower utility bills, also reduce urban flooding and promote sustainability building practice, which is it helps reduce our use of regular water from the buildings. Now, the benefit is reduce soil erosion, but it's also help promote healthier plant growth. It provides emergency water supply, and it offers long-term cost savings, which is it saves money on water bills. Next, we have green roof with native vegetations. It is a roof covered with plants. So the process attached shows the layer which the plants help cool the building by absorb heat and providing shade. So this part of MICRIS are related to building orientation and passive design features that enhance energy efficiency and thermal comfort. So it is aligned with MICRIS, which is the green roof acts as a passive cooling system, reducing heat gain and lowering the need of mechanical air conditioning. It's by using native plants, it's require less water and provide habitat for local wildlife. The benefits are improved energy efficiency by reducing cooling demand, which is reduced aircon, mitigates urban heat island, which is it's cool down the building by reducing heat, and improve local biodiversity. Moving on to the third innovation, which is recycled aggregate concrete. So the process is simple. As we can see, the old concrete is crushed into small piece, and then it's mixing it, and then it will produce recycled aggregate concrete. These sub-criteria are focused on using low impact and sustainable materials to reduce the environmental footprint of buildings, which is the RSC use recycled materials, replacing natural aggregates to reduce construction waste and the need of the raw resources. And then the concrete is processed to meet quality standards, reducing the need for new raw materials. So the benefit is reduce landfill waste, lower embodied carbon, which is lower making a new concrete, and support the circular economy. Lastly, we have low emissivity, which is low E glazing. So this is a special windows that keep heat outside and let the lights in. So here is the layers. It is a special coating on the glass that reflects heat. So for this part, the MICRIS criteria are focusing on energy efficiency and indoor environmental quality, which is the low E glass reduce heat transfer by reflecting infrared, which is IR radiation, which allowing visible light to pass through, improving thermal insulation. The second one is this result in lower energy consumption and improve indoor comfort for building occupants. The benefits are reduced cooling costs, improve indoor air quality, and enhance energy efficiency in hot climates like Malaysia, where energy efficiency are priority. So that's all from me. Thank you.
So for the conclusion, civil engineers are crucial in designing safe, sustainable and ethical buildings. They ensure structures withstand natural disaster and follow safety regulation to protect the public. Use low carbon materials and energy efficient systems to reduce environmental impact. Through innovations like green roof, rainwater harvesting and recycled concrete, they support sustainable development, promote long-term environmental and social well-being. Ultimately, civil engineers advocate for balanced safety, sustainability, and functionality in building design.
Thank you for watching.